These are the solutions to your review sheet. Be sure to follow along and correct anything you missed or left out. On number 1, we're trying to work backwards to find the number that Ben started with. Part A says we need to write an expression to represent the operations that Ben used. The big thing to remember is that an expression does not have an equal sign, and an equation does have an equal sign. So as we start, we can use X to represent Ben's starting number. It's always a good idea to define your variables. That just means that you state what variable you're using and what it represents. Okay, with this variable, we are going to start with that number. We're going to add 5, so that would be X plus 5. Multiply that sum by 3, so I'm going to put parentheses to show that I'm going to add first, and then whatever I get, multiply it by 3. And then finally subtract 4. Okay, so again, an expression, we are not going to be using an equal sign. We're just going to use the variable and the numbers that represent the steps that Ben took. Then on part B, we're going to set up an equation. We'll start with the expression we have, and then use an equal sign to make it an equation, and on the other side, we're going to set it equal to 23. Okay, the other piece of part B is to figure out what the value of X is. So I'm going to start by adding 4 on each side. That's going to cancel out with the negative 4. Those are 0 pairs. So 23 plus 4 is 27. And I'm going to bring down everything else I have. So I have an equal sign, and then X plus 5 times 3. Now I need to use the distributive property. I know it's set up a little bit backwards from how we're used to seeing it, but we're still going to distribute 3 to each of the pieces inside of the parentheses. So 3 times X is 3X, and 3 times 5 is positive 15. So now we get 3X plus 15 equals 27. We can continue solving by subtracting 15 from each side. So we have 0 pairs again. We're left with 3X, and 27 minus 15 is 12. And so next we are going to divide by 3 on each side to get X equals 4. And then on part C, we can answer with a complete sentence and just write Ben's starting number was 4. All right, part 2, circle the letters of the equations that have the same solution as 3x minus 9 equals 33. So I'm going to begin by solving this equation to know what solution I'm looking for. In a two-step equation, we're going to add 9 on each side first. Cancel 0 pairs. So we get 3x equals 42. And then divide by 3 to get x equals 14. So we're looking for the letters that are equal to 14. Okay, part A, if I divide by 3 on each side, I get x equals 11. So that one can't work. I'll cross that off. Part B, add 3 to each side. We get x equals 14. That one does work. I'm going to keep going just to make sure that there aren't any others that will also work. Part C, add 3 to each side. So we get 3x equals 33. And when you divide each side by 3, you get x equals 11. So C does not work. Part D, I need to distribute. So I have 3x plus 9 equals 11. Subtract 9 from each side to get 3x equals 2. and that has a final answer of x equals 2/3, so part D does not work. And part E, 3x minus 9 equals 33. And already I can see that that's actually my starting equation, so it's going to have the same solution of x equals 14. So this happened to have two answers. B and E are both equal to 14. Number 3, is 5s plus 1 equivalent to s plus 1 plus s plus 1 plus s plus 1 plus s plus 1 plus s? Yes or no, and why? So when I simplify, I'm going to combine like terms. So I have 1, 2, 3, 4, 5 s's. So in green, 5s. And in red, I have 1, 2, 3, 4. So 5s plus 4. And when I explain, I can say no, 5s plus 1 is not equivalent because the expression simplifies to 5s plus 4. So it's 3 off of what the question was asking. Number 4, write an expression with at least 7 terms that when simplified equals 5 times the quantity of x minus 2. I'm going to begin by distributing and simplifying the expression. So 5 times x is 5x, and 5 times negative 2 is negative 10. Now this has an infinite number of solutions as long as I make sure that my terms add up to 5x for the ones with the variable and add up to negative 10 for my constant terms. I can do anything that I want. So I could even just do 1x plus 1x plus 1x plus 1x plus 1x because that will combine to 5x. So far that's 5 terms, so I need at least 2 more. And then maybe I'll just do minus 5 minus 5, since negative 5 minus 5 would be negative 10. So there's just a basic way to do it. Again, there are an infinite number of options. You could even be a little bit more creative and do something like 2x plus 3x plus 10x minus 5x minus 5x. So all of that would add up to 5x. And then plus negative 20 plus 10. So negative 20 and 10 would add to negative 10. So 2 options. Again, as long as you have 7 terms, they need to be separated by addition or subtraction symbols. One mistake that I often see, it does not work to do something like this and then multiply all of that by x plus 2. This does not work. And the reason why is because when you follow order of operations, you actually need to distribute before you add. You always need to multiply before you add or subtract. So on the red example, 1 times x would be 1x. 1 times 2 would be positive 2. So then if I bring down the other pieces of what I have, this expression is actually equal to 1x plus 6, and that's not equal to what we have before. So just be careful. You have to have 7 terms separated by addition or subtraction. Don't try to shortcut it and just find something that adds up to 5. Okay, next, if we multiply the quantity of x thirds plus 4 ninths by 9, we get 3x plus 4. So that's a true statement. It's asking, is 3x plus 4 an equivalent expression to x thirds plus 4 ninths? Yes or no, and explain why. Right away, we can kind of see that those aren't the same. We know that 4 ninths is not equal to 4, x thirds is not equal to 3x. Also, if you take any expression and multiply it by something, you're going to get something that's not equal to what it was before. So with an explanation, we could also include something about evaluating the expression. So if I use just a really basic number, I'm going to use the number 1, and I'm going to substitute it into each expression to see if they're equal. So I have x thirds plus 4 ninths would be 1/3 plus 4 ninths. When I get common denominators, that would be 3 ninths plus 4 ninths, which equals 7 ninths. Then on the second expression, 3x plus 4, when I substitute in 1, I get 3 times 1 plus 4, which is 3 plus 4. And that simplifies to 7. And again, we can see 7 ninths and 7 are not equal. They are not equivalent. So multiplying the expression by 9 does not keep the two expressions equal to each other. Okay, next we have a worked out problem, and we need to find the mistake. Once we find the mistake, we can correct it. So in the first step, we see that they distributed the 2 into the term of x minus 6. So we're multiplying 2 times x is 2x, and 2 times negative 6 is not negative 8. This term right here should actually be negative 12. So we've already identified a mistake. We can say that the mistake was made while distributing on step 1. The 2 should be multiplied by negative 6, not added. So now when we correct it, I'm going to copy the entire expression as it started. And this time we're going to make sure we multiply when we distribute. So 2 times x is 2x. 2 times negative 6 is negative 12. Plus, and then we don't really need the parentheses anymore because we're not needing to distribute or multiply. We're just adding. Now we're going to combine like terms. So I have 2x plus 3x minus 6x, or plus negative 6x. So that would be 5x minus 6x, which would be negative 1x. And then when we combine negative 12 and positive 12, we get 0. So we can write this as negative 1x plus 0. And if we simplify it even further, we just get negative x. All right, on to solving equations. The first couple are two-step equations. So on part A, I am subtracting 3 on the same side as the variable. So to undo subtracting 3, I need to add 3 on each side. That gives a 0 pair. 19 plus 3 is 22. So I'm going to bring down everything else. 22 equals negative 4k. And now I'm going to divide by negative 4 on each side. So make sure you're dividing by the entire coefficient, not just 4. These two numbers should match when you divide. That's what's going to make it a positive 1k. And then on the other side of the equation, 22 divided by 4, I can rewrite as a mixed number. So 4 goes into 22 5 times, with 2 out of 4 left over, or negative 5 and 1/2 is equal to k. All right, we do need to check our answer. So in order to do that, I'm going to copy the equation that I started with. 19 equals negative 4k minus 3. And in place of the variable, I'm going to substitute negative 5 and 1/2. And sometimes it's easier to write it as a decimal, especially if you're multiplying. So we're going to multiply negative 5.5 by 4 to get 22. A negative multiplied by a negative is a positive. So we have 22, and then we're going to bring down everything else. Okay, next we will subtract 22 minus 3 is 19. So we get 19 equals 19, and that proves that our answer was correct. On part B, I'm going to subtract 10 and 2/10 from each side. Here are my zero pairs. So I have negative 8n. And then for the subtraction part, 10.2 is larger than 1.4. So when I subtract, I need to put the number with the greater absolute value on top. Okay, we'll borrow from 10 to get 8 and 8/10. Next, we will divide by negative 8 on each side. So we get 1n equals negative 1 and 1/10, since a positive divided by a negative is a negative. All right, now to check our answers, start with the original equation. And in place of n, we're going to substitute negative 1.1. And as I set this up, I can see that a negative times a negative is a positive, so I'm going to end up with something other than 14. So if I go back to my work, I actually subtracted more negative than what I had, so this should have been a negative 8.8, and a negative divided by a negative would be a positive. So this would actually be n equals positive 1 and 1/10. Okay, so that was a mistake, but I was able to catch it on the check it step. So now I'm going to multiply negative 8 times 1.1 is negative 8.8. Bring everything else down. And 10 and 2/10 minus 8.8. And I get 1 and 4/10, and that's exactly what I did. Okay, so now I know that my answer of 1 and 1/10 is correct. Part C, we need to distribute as the first step. So negative 7 times y is negative 7y. Negative 7 times 5 is negative 35 equals negative 42. Add 35 to each side. And I get negative 7y equals negative 7. Divide by negative 7 to get y equals positive 1. Okay, for the check it step, plug in 1 in place of y. And this time, we don't really need to distribute. We can just follow order of operations. 1 plus 5 is 6. And negative 7 multiplied by 6 is negative 42. Okay, so 1 would be the correct value. All right, part D, we have some fractions. So this was negative 7/4 x plus 3/5 equals 1/20. I'm going to begin by subtracting 3/5 from each side, so I'm still going to take care of the constant first. So here is the zero pair. And then now I need common denominators to add. So I can rewrite both of them out of 20. So 1/20th. And negative 3/5, I'm going to multiply top and bottom by 4. So I get negative 12/20. Now I can subtract those. 1 minus 12 is negative 11/20. And then bring down the rest of the equation, negative 7/4 x. Okay, next, in order to get rid of the coefficient, I can divide by negative 7/4. That would work. An easier way would be to multiply by the reciprocal. So I'm going to multiply by negative 4/7 on each side. And when I do that, negative 4 multiplied by negative 7 is 28. 7 times 4 is 28. So I get 28 over 28, or that's equal to 1. So 1x. And on the other side, Negative 11 multiplied by negative 4 is 44. 20 multiplied by 7 is 140. And I can divide by 4 to simplify. So 44 divided by 4 is 11. 140 divided by 4 is 35. So my final answer, x equals 11/35. Okay, now to check it. Negative 7/4 multiplied by x plus 3/5 should equal 120. So right here in place of x, I'm going to substitute 11/35 and we'll multiply first. So negative 7/4 multiplied by 11/35 is negative 77 over 140. And now we're going to add to get a common denominator with 3/5 and 77 over 140. I'm going to figure out what 3/5 would be equal to with the denominator of 140. So 3/5 would be equal to 84 out of 140. So in place of 3/5, do 84 over 140. Okay, next. Negative 77 plus 84, that is the same operation as 84 minus 77. So that combines to be 7 out of 140. And then I'm going to divide by 7, which is going to simplify down to 120. That's what I wanted it to be to show that my solution is correct. Next, write an equation, then solve. Answer the question in a complete sentence with units. A cell phone company charges a monthly fee plus 25 cents per text message. The monthly fee is $25 and you owe $49.50. How many text messages did you send? Okay, we're going to start by defining our variables. So we can say T represents the number of text messages. Okay, since it is 25 cents per text, I can write that as 25 cents multiplied by the number of texts, or 0.25 T, 2,500 is T. Then you pay a monthly fee of $25, and altogether that adds up to $49.50. So this is a two-step equation. I'm going to subtract 25 from each side. Pull my zero pairs. So I now have 2,500 T equals $24.50. Next, we'll divide by 25 cents. So we'll set up our division problem, 24.5 inside the division box and 0.25 outside. I need to make sure the number I'm dividing by is a whole number, so I'm going to multiply by 100, which will slide the decimal point over 2 places in each number. So this is the same division problem as 2,450 divided by 25. So 25 goes into 245 9 times to get 225. Subtract, bring down the 0, and 25 goes into 208 times. So I get a value of 98 for T. Now I can use that to answer in a complete sentence and say, if your cell phone bill is $49.50, then you sent 98 text messages. And by writing a sentence, it also helps to make sure that you have units on your answer. So 98 text messages. Next is a geometry example. We're going to solve this using arithmetic, and we're going to solve it using algebra. With arithmetic, this is where you kind of just work backwards. You don't need any variables. You're not going to use any equal signs to make it an equation. We can start by multiplying. So we have our volume, and then we have two side lengths. So if we multiply our two side lengths, we can then divide our total volume by the two side lengths. And that'll give us the third side length of 7 inches. And that represented the width. Okay, now if we're going to solve this in a little bit more of an organized way, more algebraically, we're going to substitute in to our equation volume equals length times width times height. In place of volume, I'm going to put 693. In place of length, I'm going to put 9. In place of the height, I'm going to put 11. And then everything else, I'm going to drop down. So equal sign multiplied by width multiplied by 11. Now I can start to simplify. 9 times 11 is 99. So I have 99 times the width equals 693. And then to solve, we're going to divide by 99 on each side. And we still get the same value of 7 equals width. And then we'll make sure we have units. So that should be 7 inches. All right, almost there. Final one, you need to be able to recognize your properties. So make sure you have definitions for commutative property of addition, commutative property of multiplication, associative property of addition, associative property of multiplication, distribution property, and additive inverse. So you can consult back to your notes if you need help with definitions for those. On the first step, the only thing that's switching is the order of 14 plus 2z. So when you switch the order, that would be the commutative property, because commute means to move. So that would be the commutative property of addition, since I'm adding and not multiplying. Then going from the second step to the third step, the only thing that we're doing, this is called factoring out a z. And that's kind of undoing the distributive property. So we've looked at how you can multiply the z back through. So if you have negative 3 plus 2 times z, you can distribute this way to get negative 3z plus 2z. So it's the distributive property. They're just showing it backwards. So that's what we would list. Do pay attention to spelling on all of your properties. They are spelled correctly on your review sheet, so you can use that to study as well. All right, once again, make sure that you have filled in anything that you've missed to make it all correct, and use this study guide to prepare for your test, and good luck.